Okay, so this part is finding points of intersection on the graphs. We've learned how to draw a sketch on the previous videos. So again, we're just going to sketch our graphs, and then we will, let me expand it. We will find the point of intersection, and then we'll find the number of roots that the graphs have, and then we'll write a suitable equation to find the roots. So first up, drawing y equals x squared graph. Just looks like a parabola, so I'll just draw that, sketch it out. Next one, I'm gonna solve it. So when y equals 0, x equals 0, and if I factorize this, I have x minus 1 and x plus 1, as it has a difference of 2 squares, so it'll be minus 1 and plus 1 where it crosses. Next up, when x equals 0, y equals 0, I times everything by 0, make it 0, and then I take the limits. When x goes to infinity, y goes to positive infinity, x goes to negative infinity, y goes to negative infinity. So I'll just draw that graph. I'm just going to quickly, because we've looked at this already, so boom, cuts at minus 1, comes back down to 0, and it goes back up to minus 1, and it'll just go up from there. Okay, so this should be a straight line. So again, we see our point of intersections is here, 1, 2, and 3. So part 1 is drawing the graph, part 2, our point of intersection is 3, and part 3, write a suitable equation. I'm just going to substitute my y equals x squared into my second equation. So x squared equals x times x squared minus 1. We don't need to solve it, just asking for the suitable equation. Alright, part 2. I'm just going to quickly draw this graph. So isotope graph minus 2x. So I'll do this side in red. It's the easy graph to draw. So it's going to look like this. Boom. I'm going across like that. And now I can see it's the x cubed graph, a minus x cubed graph. So again, I'm just going to work out all the intersections. Okay, so first up, when y equals 0, x equals 0, and it equals 1. Yeah, 1 minus x equals 0, so therefore x equals 1. And that's it for that. When x equals 0, y equals 0, to multiply everything by 0, and taken to the limits, it's a negative graph. So when x is going to infinity, y is going to negative infinity, and vice versa. When x is going to negative infinity, y is going to infinity. So this graph looks something like this. It's going to be coming from here, cutting the other equation, going through 0. Let me draw a straight line. It's been coming like this, cutting through, touching 0, going back up, and then coming back all the way down, cutting at 1 here. Okay, so I forgot to label this. This should be 1, and that should be minus 1. Okay, cutting at 1 there. So again, our point intersection 1, 2. So our point intersection, so it has 2 roots. So 2 points of intersection, not roots. And part 3, to find a suitable equation, I'm just again gonna substitute x squared 1 minus x equals minus 2 over x. Okay, cool. And the last example we're going to look at, negative x cubed graph. So it's going to come, this one being in black, so it's going to come and it's going to go through 0. A pretty easy graph to draw. So come through here, go through 0, and come down, yeah, going to infinity. And here we have a negative x squared graph, x squared minus 2x. So that's gonna cut. So we have y equals minus x squared minus 2x. That's the graph I'm gonna draw. Again, when y equals 0, x equals 0 and minus 2, and when x equals 0, y equals 0, so that'll be the y-intercept, and it's a negative x squared graph, so it's going to look like this. It's going to come up from here, boom, cut at minus 2 and cut at 0 again and keep going down, and it's going to go down forever. I'm just going to draw x, and if I just extend the x cube graph, boom, they will eventually meet. Yeah, sometimes you just have to imagine it, or you could keep drawing the graph and they will eventually meet. So therefore my points of intercept is going to be 3, and this should be minus 2. Label that. My equation, again, I'm just going to substitute plus 2. Okay, so that's 3 examples of that chapter.